Hello everyone, welcome to GGRC12 Tutorial 2. In this lab, we are going to conduct network analysis in ArcGIS Pro. Please find the tutorial videos at my YouTube channel, and also you can contact me via email if you have any questions. In this exercise, you are going to conduct network analysis in ArcGIS Pro and solve a series of transportation problems. The data are combined into the zip file. I have uploaded it to Crocus. You can find it and download the zip file. In this lab, you will learn some practice exercise drawn from a popular GIS test. I will give you step-by-step instructions on generating a network dataset in ArcGIS Pro and using this type of data to solve routing and service area problems. Afterward, you will use this knowledge to conduct analysis using several Toronto-based datasets. Before you start, you have to read the Chang's book chapter. This book chapter introduces specific GIS concepts related to network analysis. You will also need to get access to ArcGIS Pro software. Please check the following website for the instructions to install ArcGIS Pro to your computer. You can also use the computers in the lab to finish this assignment. Now, let's start from part 1, textbook applications of network analysis. The first task is to build a network dataset. First, open ArcGIS Pro and create a new project for this assignment. I will name it A2 US because it's about some US cities, and find a location to save your project. First, you can add folder to your quick access. We're going to add Tron data folder and go to add data. Then you can find the folder in this quick access. Click on Tron data and we are going to add 2 layers to the map. The first one is interstates and the second one is US cities. After loading the layers, you can right-click on the layer and export the layer to your own geodatabase. I'm going to give it another name. This step will let you save the layers into your own project, so it is very important because you will use these layers later in the network analysis. Click OK to export the layer, and then you can remove the original layers. Open the catalog pane, go to Folders, A2, and A2 Geodatabase. Now you have 2 layers. Right-click on A2, go to New, add a new feature dataset. I'm going to give it a name of network, US city network. And you need to set the coordinate system of the new feature dataset. We are going to import the coordinate system of US cities so that they are using the same coordinate system. Then click Run. And then you can drag the US cities, interstates to the feature dataset. Right-click on US city network, add a network dataset to it. I'm going to give a name of driving network dataset and check interstates as the source feature classes. Click Run. And now you can find there are some green lines on the map showing the network dataset. You can also refresh the US city network and you can find a network dataset here. Again, by refreshing US city network, you will find the network dataset here. Uncheck other layers on the map. You will see a gray networks. But first, let's remove the network for a while because we need to set the properties of it. And we're going to check the attribute table of the interstates layer because in the attribute table we will find some useful information to set the properties of the network. So here are the lengths of the interstates, highways, and the minutes traveled between the highways, also the name. So we go to the properties of the network dataset and go to travel attributes. Click on costs. So here we are going to define the costs travel between the network points. Here we use the name travel distance. And I'm going to use an expression for it. I'm going to use trip length, which is the length of the highway, to stand for the cost of the network. Then click on OK. Right-click on the network dataset and build the dataset. It will take a few minutes for building the network. Now the network has been successfully built, and you can check it later. Task 1B is about finding the shortest route using the network. Now we can use the network to do some analysis. Go to Analysis, Network Analysis, make sure you are using the correct network, and click on Route. Here are some elements of the road analysis, and you can go to Network to explore it by randomly clicking on any of the highways. Now I'm going to select two cities from the US cities layer. I'm going to use city name and select two cities, Helena and Charlotte. Here are the two cities, and I'm going to export the feature to a new layer. Then we will use this layer to calculate the shortest route between the two cities. Click on Route And import stops. We're going to import the two cities as two stops on our network. So here are imported stops numbered 1 and 2. And with these stops, we can run the shortest road analysis. The purple line shows the shortest road from point 1 to 2. And the network analysis is based on interstate highways in the US. We can also find the shape lines here, which shows the travel distance between the two stops. Sometimes we need to add point barriers to the road. Click on Edit and add point barriers to the road. Click on Save to save your edits. Then go to the road analysis and rerun the shortest road analysis. You can see that the updated road has been avoided the point barriers. For your assignment, you will have to put your map on a layout. Click on Layout to add a new layout and click on Map Frame to insert the map to the layout. You can drag a rectangular on the layout. You can also adjust the position of the map by activating the map frame. Here, click on Activate, and you can drag your map frame and change the position of it to make it at the middle of the page. Then close activation. Go to Insert to insert North arrow and scale bar and legend for your layout. You can right-click on these elements to change the properties of them. After you have done your settings, export the layout as a JPG or PDF file so that you can insert it to your assignment. You will also need to add a title to the map and also add your name and student number on it. Right-click on the title box and change the settings of the title box. You can give it a background. You can also make the test at the middle of the box. Again, you can share your layout by exporting it. Task 1C is to find the closest facility using the network. In this task, we are going to find the nearest airports from Charlotte. So first we have to select Charlotte from the US cities or from Helena, Charlotte. And we can also change the symbol of the Charlotte to make it more clear on the map. I'm going to use a red star. And you will also need to add airport data of the United States from the provided dataset. And then we choose closest facilities. We first need to import facilities. The input locations is Airport USA. You can just ignore the warnings. And then we are going to import incidents. This time we use Charlotte. And in this task, we are going to find the 5 closest facilities from Charlotte. Click Run. Now we can see the results. Here are 5 roads showing the 5 closest facilities. Open the attribute table of the roads. You can see the total travel distance from Charlotte to each airport. You can select one to check the details. We can zoom in the map and to see the details or the name of the closest airport. Task 1D is to find service area using the network. First, I'm going to use a subset of the airport dataset. I'm going to select 3 areas in New York City. I use ITA code. So the 3 airports in New York City is JFK, EWR, LGA. Click on Apply, then export the feature as a new layer. I call it NYC Airport. Now we can zoom in the map and check the locations of the 3 airports. Go to Analysis, Network Analysis. I'm going to change the data source here. I use ArcGIS default network because we are using the network in the city rather than the interstate highways. I'm also changing the point symbol formats to make it bigger on the map. Then go to Network Analysis and select Service Area. We can import facilities using NYC airports. Then we can do the analysis based on driving distance. The cutoffs here are 30, 50, and 100 kilometers. And I use dissolve in output geometry. The results will show the service areas from the 3 airports. Here are the service areas of the 3 airports. And the shape area shows the total area of each service area. We can also use driving time as the criteria and set the cutoffs 30, 60, and 90 minutes, which shows the 30-minute service area and 60 and 90 minutes service area respectively. You can run the analysis and see the updated results. Here is the updated service area analysis. By opening the attribute table, we can see the updated service area from the 3 NYC airports. Part 2 is the application of network analysis in Toronto. You will use what you have learned in Part 1 to create a network dataset for the City of Toronto and answer questions by conducting several network analysis. The steps are pretty similar to Part 1, so I'm not going to show you the details here. That's all for the Lab 2 tutorial. Thank you so much for watching the video. If you have any questions, please feel free to reach out, and I will try my best to help you. See you!